Session 2017, number 1, exercise number 2. So the aim of this exercise is to determine the capacitance of a capacitor, but by two different methods. Consider the circuit presented in document 1. It's formed of an ideal generator that maintains across its terminals a constant voltage E, where we have a capacitor, capacitance C, and two resistors R1 and R2, and a double switch. So the first part, charging a capacitor, it's initially neutral, and at t equals to 0, put the K at position 1, so now it's charging. Part 1, show that the differential equation is of the form E equal R1C duc over dt plus uc. In order to find the differential equation, we'll start with the law of addition as usual. Law of addition of voltages, which means that E, which is UG, is equal to U of the capacitor plus U of the resistor 1. This means it's equals to UC plus R times I, R1. We know that I is equal to dQ over dt, which is equals to TD CUC over dt. This means C DUC by dt. And then we substitute here, so we'll get E equal U of the capacitor plus R1 times C DUC by dt. The question is to verify this equation, so it's verified. Second part. Now, the solution of this differential equation has the form UC equal A 1 minus E minus T to the power T1. So the question is, determine the expression of the constant A and tau1 in terms of E, R1, and C. Since it's a solution, this means it verified the differential equation. So first we'll do expand. So we'll have UC equal A minus T over tau1, and we'll put the differential equation. So we already had that E equals to R1 C duc by dt plus UC. We can divide all the equation by RC if we want. So if we divide by RC, we'll get duc by dt plus UC over R1C is equal to E over R1C. And then we'll substitute. I have UC, but I don't have duc over dt. So we'll do a derivative here. The derivative of A is 0. Here the derivative is minus A bracket minus 1 over tau, E minus T over tau1. And then we'll substitute. So this means A over tau1, E minus T over tau1, plus UC, يعني هيدي كلها, and over R1C. So A over R1C, and we continue, minus A over R1C, E minus T over tau1, and we'll bring this part, this one here, so equals to 0. And then we can take a common factor. So بناخد اللي فيهم exponential. This means E minus T over tau1, and I have A as common factor. So we still have 1 over tau1 minus 1 over R1C. واللي ما فيهم exponential. So we have 1 over R1C bracket A minus C. It's equals to 0. And then now we'll say that this part minus 1 over R1C is equal to 0, which means that tau1 is equal to R1C. It's the first unknown. The second one, A minus E, is equal to 0, which means that A is equals to E. So this is the second one. Now, part 3, deduce that UC is equals to E at the end of the charging. When we say at the end of the charging, this means at T equal infinity. So here part 3, we'll say at T equals to infinity, we have UC equal A, we got A, it's equals to E, so I can put it E here. So it's E minus T over tau1. At T equal infinity, this means that this is E to the power minus infinity, which is equals to 0. So this part is all equal to 0, so which means that UC equals to E. So it's verified. Now, experimental study, in order to determine the value of C, we use a convenient apparatus which traces during the charging of the capacitor the curve representing len of E minus UC. Part 1, determine using the solution of the obtained differential equation the expression of len E minus UC. We already have that the solution of the differential equation is of the form UC equal E minus T over tau1. Then the question is find len of E minus UC. So first I'll bring E minus UC to one part. So this is E minus UC is equal, so جبنا هيدي لهون. This means it's equal E minus T over tau1. But I want len, so I'll put len here. And I put len to the other side. And the question is determined in terms of E, R1, C, and T. So محل T1, I can put R1, and then we can continue also. So this means this is the form I can continue here. And len of A times B is equal to len A plus len B over R1C. And then now this means that len of E minus UC is equal len للE بتبقى مثل ما هي. And here we have len of E to the power x is equal to x. So شو بقى لنا هون minus T over R1C, since between bracket len E to the power n, so it is equals to n. So this will be the equation in the part 1. Show that the shape of the curve in document 2 is in an agreement with the obtained expression. So if I look here at the graph, this is 1, 2, 2. The graph shows us a line not passing through the origin and decreasing. And if I look, so first I will say that according to the graph, I have a line not passing through the origin and it's decreasing. Which means that, does it verify the equation here? So if I look at the equation, I have len of E minus UC is equals to minus T over R1C plus len of E. This is Y here, equal. And T here by an X, so it's X. So this part, all this part is A, is the slope. And this is a constant here, so it's plus B. So yes, it verifies the equation. And I also have, since it's a line, it's the equation of line, plus I must say that the slope is negative. So A is negative, which means it's decreasing. So yes, it verifies the equation, the graph. Using the figure of the curve of document 2, determine the values of E and C. Now, in order to determine the value of E and C, we should now substitute. So we can substitute, or we can find, you can use the slope. If I want to use the slope, for example, here, we already said, part 1, 3, that the slope is equal to minus 1 over R1C. So I can find C if I have the slope. How to find the slope? So A equals to the slope equals to Y final minus Y initial, which is, for example, I can take, for example, the 2.5. This is the final minus the 3. So it's 2.5 minus 3 over, this is here, 0.01 minus 0 minus 0, which will be equals here to minus 50. So this is the slope. Now I substitute minus 50 equal minus 1 over R1, which is given. So كنا احنا معنا R1 C. This means we'll get C equals to 2 microfarad, 2 times 10⁻, minus 6 farad. This is how we find C. But we still have to find E. And we know that in order to find E, I can take which time? So I can take at the time, for example, T equals to 0. So at T equals to 0, what do we have? At T equals to 0 here, so this is the equation, len of E minus UC is equals to 3. At T equals to 0, I have 3 equal, the time will be equals to 0, plus len E, which means len E is equals to 3. This means if I do the exponential on the calculator, I get that E equals to 20 volts. We continue. Discharging of the capacitor. The capacitor now being fully charged at an instant t taken as unit origin of time, the switch K is placed at position 2. So we have a discharging phenomenon. Show that the differential equation across the capacitor is of the form UC plus alpha duc by dt, where alpha is a constant to be determined in terms of R1, R2, and C. So the question is to find the differential equation. So here we have UC equals to UR1 plus UR2, which means it's equals to R1I plus R2I, and I can take common factor. So this is UC. I want it in terms of UC. But we know that I is equal to minus dq over dt in the case of discharging, which means equal minus c duc over dt. And then we substitute, so we'll get uc equals R1 plus R2 bracket minus C duc by dt. And then, so this means that I have R1 plus R2 C duc by dt, and plus uc is equal to 0. So yes, it's the form uc plus alpha duc over dt equals to 0. And the question is to determine alpha. So by identification of these two equations, I'll get that alpha equal to this part all, alpha equal to R1 plus R2 times C. The solution of differential equation has the form, so this is the solution of differential equation, where tau2 is a constant. Now, show that tau2 is equal to alpha. In order to verify this, so this is a solution. This means it verified the differential equation. So this is UC, I write here part 2. So UC equal E minus T over tau2. First, we'll find the derivative. So equal minus E over tau2, E minus T over tau2. And then we'll substitute in the differential equation. So by substituting in the differential equation, we'll get here, UC I'll substitute, so we'll get UC plus alpha duc over dt equal to 0. I do the substitution, so E minus T over tau2, plus alpha, which is equals, so we'll put it, and duc over dt, we already find it, so minus E minus T over tau2 is equal to 0. So we take common factor, we have E minus T over tau2, this is a common factor, and we still have between bracket tau2 and minus here, we still have E minus, this is not, we don't have here tau2, this is over, this is over tau2. So here we'll get 1, and so it will be equals to 1 here, and minus alpha over tau2 equal to 0. So this means that 1 minus alpha over tau2 is equal to 0, which means that alpha equals to tau2. So it's verified. We continue. The variation of the voltage UC across the capacitor as function of time is represented in the figure, in this figure. Determine using the document 4 the value of the time constant tau2 of discharging circuit. So in the case of discharging, we'll say that at t equals to tau, we have UC equals 0.37 of E, which is equals to 20. So equals 0.37, and we have E is equals to 20. So we'll get here equals the value to 7.4 volts. Then when I find the 7.4 volt, I put it here. This means that tau2 is equal to 0.06 second. Now part 2, deduce the value of C. So we know that tau2 is equal to R1 plus R2 times C. And we already have R1 and R2, which means that C equals tau2 over R1 plus R2. And then we'll get here as answer. So this is C is equals to, so we'll get here C equal to 2 times 10 to the power minus 6 farad, which is equal to 2 microfarad.